example 2, part A. Okay, so let us write it like this. Part A, logarithm in base 2 of 16. So if we want to calculate logarithms using the definition of logarithms, we should use this fact that there is this base 2, and when we have the base 2, we should perhaps try to aim for expressing 16 as the proper power of 2. So let me replace 16 as 2 to the power of 4, okay? Because 16 is actually 2 to the power of 4. It's 2 times 2 times 2 times 2. Now, what is the logarithm of 2 to the power of 4? Well, you know that it must be exactly 4. Now, what I'm using here is the formula that the logarithm of in base a of a to the power of y equals y, and it equals y always. So whenever you have something like this, you may interchange this logarithm with the value of y. So this is what I got by using the base 2 and the exponential with the base 2 to express number 16. Now let us do the same thing in part B, or exactly the similar thing actually. So we have the logarithm in base 5 of the number 0.2. So we should aim for expressing 0.2 as an exponential in base 5. So this is the logarithm in base 5 of. Now 0.2 is 2 over 10 or 1 over 5. 1 over 5 is exactly 0.2. So we can express it as the logarithm in base 5 of 5 to the power of -1, because 1/5 is 5 to the power of -1. And now again you have this formula here. So it's the logarithm in base 5 of 5 to the -1, so it must be -1. Okay, and this is the answer. In part C, we have a logarithm in base 10 of the 5th root of 100, okay, like that. So let us first try to evaluate this 5th root as the exponential, so replace it by an exponential, so it's the logarithm in base 10 of 100 to the power of 1/5, like that. Now 100 is 10 to the power of 2, so it can be expressed further as logarithm in base 10 of 10 to the power of 2 all raised to 1/5. And now using the exponential laws, you can rewrite it as the logarithm in base 10 of 10 to, and you have to multiply 2 times 1/5, so it's 10 to the 2/5, like this. Now the answer is obvious. The result has to be 2 over 5. So this should be the answer that solves this problem. And the reason is that we were able to transform this problem to this form, that we have the logarithm in base a of a to the power of something, and the answer is then this something. Well, in our case y, in this case 2/5. The last part, logarithm in base 2 of 1 over square root of 2. Okay, so the base is 2, so let us try to express this number in the brackets as 2 to some power. So it's the logarithm in base 2 of. So let us first start by replacing square root of 2 by the power, 2 to the power of 1/2. And now, since we have 1 over 2 to some power, we can replace it further as the logarithm in the base 2 of 2 to the power of -1/2. Okay, because we know that 1 over a to the power of x is a to the power of -x. Okay, this is the power law, one of those power laws from the previous chapter. So you see now that again we got this form here given by this general formula, so we can replace it by -1/2, like that. And this is the answer to this question.